Dr. Jai-Ho Park stared at his computer screen in the quiet hours of the morning. The only light in his office came from the screen and a small desk lamp. He had been looking at the same data for 5 hours straight at the Korean Space Research Institute, but something wasn't right. The numbers from the new space telescope didn't match what they should see. He took off his glasses and rubbed his tired eyes. The coffee on his desk had gone cold hours ago. As he reached for the cup, his phone buzzed. It was a message from his colleague, Dr. Ha-won Kim. Still at the office, her message read, "Yes, something strange in the telescope data. Can you come look?" He typed back. 20 minutes later, Ha-won walked into his office. She wore casual clothes. Clearly, she had been home when she got his message. Her long black hair was tied in a simple ponytail, and she carried 2 fresh cups of coffee from the shop down the street. "You're going to work yourself to death, Jai-Ho," she said, putting 1 cup on his desk. "What's so important it couldn't wait until morning?" Jai-Ho pointed at his screen. "Look at this area here. The stars aren't moving like they should." Ha-won leaned closer, her eyes narrowing as she looked at the data. The telescope tracked how stars moved in a small part of space. Some stars were moving in circles around something they couldn't see. "Could be a problem with the telescope," she said, but she didn't sound sure. "I checked. 3 different telescopes showed the same thing." Jai-Ho pulled up more data. "Something is pulling these stars, but we can't see what it is. And look at how fast they're moving." Ha-won's eyes widened as she looked at the numbers. That's not possible. An object that powerful would have to be." "A black hole," Jai-Ho finished, "but not like any we've seen before. It's smaller than usual. And look at where it is." He showed her another screen with a map of space. Ha-won gasped. The location he pointed to was much closer to Earth than any known black hole. "If you're right," she said slowly, "this could change everything we know about black holes. But we need to be sure, really sure." Jai-Ho nodded. "I know. That's why I called you. You're the best at checking data. If anyone can prove this is real, it's you." They spent the next few hours going over everything again and again. They checked the math, looked at more telescope data, and ran many tests. As the sun began to rise outside their window, they became more and more excited. This wasn't a mistake. This was real. "We should tell Director Lee," Ha-won said, stacking their empty coffee cups. "But first, you need to go home and sleep. You look terrible." Jai-Ho laughed. "Thanks. But you're right." He saved all their work and stood up. His legs felt stiff from sitting so long. "Tomorrow, we start proving to everyone else that we found something amazing." As they walked out of the building into the early morning light, both scientists felt the weight of their discovery. They had found something that could change how humans looked at space forever. A black hole hiding right in Earth's cosmic backyard, waiting to be studied. "Ready for all the questions and doubts we'll get?" Ha-won asked as they reached the parking lot. Jai-Ho smiled. "They can doubt all they want. The math doesn't lie. We just have to show them." They didn't know it yet, but this morning was the start of something bigger than either of them imagined. Their discovery would not only change science, it would change how humans saw their place in the universe. 1 month after their discovery, Jai-Ho and Ha-won sat in Director Lee's office. The morning sun lit up the room as they showed their findings to a group of senior scientists. Among them was Dr. Sun-mi Choi, known worldwide for her work on black holes. "Impossible," Dr. Choi said, looking at their data. "A black hole this close would have been found years ago. Our detection methods are very good." Jai-Ho took a deep breath. "What if our detection methods are wrong?" The room went quiet. "Not completely wrong," he added quickly, "but incomplete." Ha-won stepped forward and turned on her tablet. "We have a new theory," she said. She showed them a diagram of 2 particles in space. "We think black holes affect quantum entanglement in a way no one has looked for before." Dr. Choi frowned. Quantum effects are too small to help find black holes. We use gravity waves and X-rays because they're stronger. But what if we're missing something? Jai-Ho asked. He walked to the screen and pointed to their calculations. Look at these patterns. They match quantum theory perfectly. The black hole isn't just bending space. It's twisting the quantum fabric of space itself. Director Lee leaned forward in his chair. Even if you're right, how would we test this? Quantum effects are hard to measure in a lab, let alone in space. HFY smiled. We have an idea for that too. She showed them another diagram. We can use quantum computers to detect these patterns. It's like having a new kind of telescope, one that can see things we've been missing. This is very creative, Dr. Choi said, but her voice was cold. But it goes against everything we know about black holes. Do you know how many careers have been built on our current methods? Science isn't about protecting careers, Jai-Ho said quietly. It's about finding the truth. The room grew tense. Director Lee cleared his throat. Dr. Choi has a point about the risks, but he looked at the data again. There's something interesting here. I think it deserves more study. After the meeting, Jai-Ho and HFY walked to their lab. They felt tired but hopeful. That went better than I expected, HFY said. At least Director Lee is giving us a chance. Dr. Choi will try to stop us, Jai-Ho said. She's afraid we'll prove her life's work was incomplete. Then we'll have to prove we're right. HFY opened her computer and pulled up their research. We need to make our theory stronger, and we need help. Jai-Ho nodded. I know some people who might be interested. Scientists who aren't afraid to try new ideas. They worked late into the night, improving their theory. They added more math, more proof, and more tests they could do. With each hour, they became more sure they were right. As they were about to leave, Jai-Ho's phone buzzed. It was an email from a quantum computing expert named Dr. Yi-Jin Lee. She had heard about their theory and wanted to help. See, HFY said, reading over his shoulder. We're not alone. Other scientists want to know the truth too. Jai-Ho smiled as he wrote back to Dr. Lee. Maybe they were at the start of something big. Maybe they would change how humans looked for black holes forever. But first, they had to prove their theory was right. As they left the lab that night, the stars shone brightly above them. Somewhere up there, their black hole was waiting to be found. And they would find it, no matter what anyone said. Dr. Yi-Jin Lee arrived at the Korean Space Research Institute on a bright Monday morning. She carried a large bag filled with quantum computing equipment. The security guard at the front desk looked confused when she said she was there to help find a black hole with a quantum computer. Jai-Ho met her in the lobby. Thank you for coming, he said, helping her with her bag. We have a lab ready for your equipment. I read your theory 3 times, Yi-Jin said as they walked. It's amazing. If you're right, we'll need a very special computer to detect these quantum patterns. They entered the lab where HFY was working. The room was bigger now. Director Lee had given them more space for their project. Screens covered the walls, showing star maps and complex calculations. We have another visitor coming today, HFY said, looking up from her computer. Someone who knows about flying close to dangerous things in space. Right then, a tall man in a neat black suit walked into the lab. Captain Do-Hyun Kang, he said, bowing slightly. I used to fly spacecraft for the military. Now I help plan space missions. Jai-Ho looked surprised. We're not planning a space mission yet. We still need to prove our theory. Do-Hyun smiled. If you prove it, you'll want to get closer to that black hole. And that's where I can help. Better to plan early than too late. As they talked, another person entered the lab quietly. He was younger than the others, carrying only a tablet computer. I'm Min Ki-yoon, he said. Dr. Choi sent me to watch your project. Everyone went quiet. They knew Dr. Choi didn't believe in their work. Was Min Ki here to spy on them? But Min Ki continued. I think you're right. I've been working on AI systems that study space. My computers have found patterns like the ones in your theory. Dr. Choi doesn't want to listen, but I do. Had-won looked at Jiao. He nodded. Welcome to the team, she said. They spent the rest of the day sharing ideas. Yi-jin explained how quantum computers could detect tiny changes in space. Do-hyun talked about how to safely fly near gravity wells. Min-ki showed them how his AI could help process the massive amount of data they would collect. We need to build something new, Yi-jin said, drawing on a whiteboard. A device that combines quantum sensors with traditional telescopes, something that can see what other people are missing. My AI can help design it, Min-ki added. It can test millions of possible designs in one day. And I can make sure it will work in real space conditions, Do-hyun said. Theory is good, but space is always more complicated than we expect. As the day ended, Jiho looked at their new team. Each person brought something special. Yi-jin's quantum knowledge, Do-hyun's space experience, Min-ki's AI skills, and Ha-won's careful science. Together, they might really change how humans looked for black holes. Tomorrow, Jiho said, we start building our device. Dr. Choi and others may not believe in us yet, but soon we'll have proof no one can deny. They left the lab together, talking and planning. Above them, the stars were coming out. Somewhere up there, their black hole was hiding, but not for much longer. With their new team, they were ready to make one of the biggest discoveries in human history. 3 months passed as the team worked on their device. They called it the Quantum Gravitational Wave Observer, or QGWO. The lab had changed completely. Quantum computers hummed in special cooling units. Screens showed endless streams of data. Cables ran everywhere across the floor. One quiet evening, as most people had gone home, Yi-jin's quantum computer made a strange sound. She looked up from her work, pushing her chair closer to the screen. Everyone, she called out. I think you should see this. The team gathered around her computer. The quantum sensors were picking up a pattern, exactly the kind of pattern their theory had predicted. Min-ki, Jiho said, can your eye confirm this? Min-ki was already typing rapidly on his tablet. His AI systems analyzed the data in seconds. It matches, he said, his voice excited. The quantum pattern is real, and there's more. He moved the data to the main screen. The AI found something we missed. The pattern repeats. It's like watching a dance. A binary system, Ha-won whispered. Everyone looked at her. Our black hole isn't alone. It's dancing with another one. That's why the pattern repeats. Do-hyun stepped closer to the screen. 2 black holes. Are you sure? That would be incredibly rare, especially this close to Earth. The math is clear, Yi-jin said, running more tests on her quantum computer. We're picking up quantum echoes from 2 massive objects spinning around each other. Both are definitely black holes. Jiho sat down heavily in a chair. This is bigger than we thought. One nearby black hole was amazing. But 2, dancing together. This could teach us more about space and gravity than we ever imagined. The team worked through the night, checking and double-checking their results. The QGWO kept sending data, confirming their discovery again and again. As the sun rose, they couldn't deny it anymore. They had found something extraordinary. We need to tell Director Lee, Ha-won said. And, she paused, we should tell Dr. Choi too. She needs to see this. An hour later, Director Lee and Dr. Choi stood in their lab. Dr. Choi looked at their data in silence for a long time. Finally, she spoke. I thought you were wrong, she said quietly. I was sure your theory about quantum patterns couldn't work. But this, she pointed to the screen. This is real. You've found something no one has ever seen before. Director Lee was already making phone calls. The international space agencies will want to know about this, he said. And we'll need funding. Lots of funding. For what? Jiho asked. For the next step, of course. Director Lee smiled. We need to get closer to these black holes. We need to study them properly. Captain Kang, how soon can you start planning a probe mission? Do-hyun straightened up. With this team, we can start right now. As their colleagues rushed around making plans, Jae-ho and Ha-won stood by the window. The morning sun made the city glow. We did it, Ha-won said softly. We really did it. We're just getting started, Jae-ho replied. Those black holes have more secrets to tell us, and now we know how to listen. The QGWO kept running, recording the cosmic dance of two black holes that had been hiding in plain sight. Humanity was about to learn some amazing new things about the universe. The International Space Conference in Geneva was packed with scientists from around the world. Jae-ho stood on the main stage, showing the results from their quantum gravitational wave observer. Behind him, a large screen displayed the dance of their binary black holes. As you can see, he said, these black holes are closer to Earth than any we have found before, and they're teaching us new things about how space itself works. In the front row, Ha-won and the rest of the team watched proudly. Dr. Choi sat with them, nodding as Jae-ho explained their discovery. She had become their strongest supporter, using her fame to help spread word of their work. After Jae-ho finished speaking, the questions came quickly. Scientists from NASA, the European Space Agency, and space programs around the world wanted to know more. How did the quantum detection work? Could they build more QGDOs? What else might these devices find? Wei Jin stepped up to answer the technical questions about quantum computing. Min Ki explained how his AI helped process the data. Do-hyun talked about their plans to send a probe to study the black holes up close. This changes everything, a famous scientist from NASA said. We've been looking for black holes the wrong way all this time. Your team has opened a new door to understanding space. During the lunch break, Director Lee brought exciting news. The International Space Coalition wants to fund your probe mission, he told the team. They're calling it a top priority for human space science. All the major space agencies want to work with us. Ha-won added. They're offering to share their best technology and scientists. Jae-ho looked around at his team. 6 months ago, they were working alone in their lab, doubted by almost everyone. Now they were at the center of the biggest space research project in history. That evening, there was a formal dinner for the conference scientists. The team sat together at a special table near the front. The head of the European Space Agency stood up to make an announcement. The Korean Space Research Institute's discovery is the most important breakthrough in black hole science in 50 years, she said. Their probe mission will be humanity's first real chance to study these mysterious objects up close. We are proud to support their work. After dinner, the team walked through Geneva's old streets. The stars shone bright above the city's ancient buildings. It doesn't feel real, Yi Jin said. A few months ago, I was just working on quantum computers in my small lab. Now we're planning humanity's first close study of a black hole. It's real, Do-hyun said. And soon we'll be building the most advanced space probe ever made. We'll see things no human has ever seen before. The hard work is just starting, Min Ki reminded them. Building the probe will be much harder than building the QGDO. We'll need my AI systems to work perfectly. Jae-ho stopped walking and looked up at the stars. Somewhere up there, their black holes were spinning around each other, waiting to share their secrets. Thanks to his team's work, humans would soon understand these cosmic mysteries much better. Whatever challenges come next, he said, we'll face them together. We've already proved that the impossible is possible when we work as a team. They stood there for a moment, 5 scientists who had changed how humans looked at the universe. Their story was already amazing, but the most exciting part was still to come. The launch control room at the International Space Center buzzed with activity. Screens showed the status of their probe, named Hawking's Dream. After 6 months of preparation, they were ready to launch humanity's first dedicated black hole study mission. Do-hyun sat at the main control station, checking all systems one final time. The rest of the team watched from their stations. Each had a special role in the mission. Yi Jin monitored the quantum sensors. Min Qi's AI systems controlled the probe's advanced functions. Hai Wen tracked the black hole's positions. Ju Ho coordinated with the international science team. All systems are ready, Du Hyun announced. Hawking's dream is prepared for launch. The countdown began. The room grew quiet. Years of work had led to this moment. The probe carried their most advanced technology, including an improved version of their quantum gravitational wave observer. Launch in 5, 4, 3, 2, 1. The rocket lifted off, carrying their probe toward space. The room erupted in applause as the first stage performed perfectly. Soon, Hawking's dream separated from its rocket and opened its solar panels. Probe systems are all working, Min Qi reported. His AI confirmed that every part of the spacecraft was functioning correctly. Quantum sensors are online, Yi Jin added. We're already getting better readings than our Earth-based QGWO. For 3 weeks, the probe traveled toward the binary black holes. Each day brought new data about space and gravity. The international science community watched eagerly as Hawking's dream got closer to its target than any human spacecraft had ever been to a black hole. Then, on day 22, something went wrong. We're detecting strong gravitational waves, Ha Won said, her voice tense. Much stronger than we expected. Do Hyun's fingers flew across his control panel. The probe is being pulled off course. These gravity patterns aren't matching our predictions. The black holes, Jai-ho realized, they're affecting space more powerfully than our calculations showed. The gravity is bending space in new ways. Warning lights flashed across their screens. The probe's structure was under enormous stress from the gravitational forces. Parts of it were starting to bend. We need to pull back, Du Hyun said. These forces could tear the probe apart. Wait, Min Qi called out. My AI is detecting something in the gravity patterns. They're not random. There's a structure to them, like waves in an ocean. Yi Jin studied her quantum readings. He's right. The quantum sensors are picking up patterns we've never seen before, if we can just keep the probe working a little longer. The room filled with tension as they watched their probe struggle against the powerful gravitational forces. Hawking's dream was discovering new things about black holes and space, but at what cost? Structure stress at 80%, Du Hyun reported. We need to make a decision. Do we stay and risk losing the probe, or pull back with what we've learned? Jai-ho looked at each member of his team. They had come so far. Their probe was showing them things about black holes that no one had ever seen. But if they pushed too far, they could lose everything. The warning signals kept flashing as they faced their hardest choice yet. The next few minutes would decide the fate of their mission, and possibly change our understanding of the universe forever. Time was running out for Hawking's dream. The probe's structure groaned under the intense gravitational forces from the binary black holes. In the control room, warning signals continued to flash across every screen. Structural integrity down to 70%, Du Hyun reported, his voice steady despite the crisis. We have maybe 10 minutes before critical damage occurs. Min Qi sat perfectly still, his eyes closed as his AI systems processed the incoming data. Suddenly, they snapped open. The gravity waves, he said, they're not random. They follow a pattern, like music. Yi Jin moved to his station, looking at his AI's analysis. He's right. The quantum sensors are picking up a rhythm in the gravitational forces. The black holes are creating it as they orbit each other. Can we use that? Jai-ho asked, looking between his two colleagues. If the waves have a pattern, maybe we can predict them. Min Qi's fingers flew across his keyboard. My AI can calculate when the gravitational forces will be weakest. If we time the probe's movements right, we can ride the gravity waves instead of fighting them. Like surfing, Ha Won said, understanding dawning on her face. We let the waves carry us where we want to go, using less power and putting less stress on the probe. Do Hyun studied the AI's predictions. It could work. But we'll need to reprogram the probe's navigation system. And we have to do it before the structure fails. The team moved quickly. Yi Jin's quantum sensors fed data to Min Qi's eye, which calculated the patterns in the gravity waves. Du Hyun used these calculations to create new flight paths for the probe. Hai-1 and Ji-ho worked together to adjust the probe's scientific instruments for the new approach. Ready for primary system update, Min Qi announced, uploading new navigation protocols now. The room held its breath as the probe received its new instructions. For a moment, nothing seemed to change. Then, slowly, the warning signals began to quiet. Structural stress decreasing, Du Hyun reported. 65%, 60%, 55%. It's working. On the main screen, they could see Hawking's dream changing its movement pattern. Instead of pushing against the gravitational forces, it now moved with them, using their power to maintain its position near the black holes. The quantum sensors are working better than ever, Yi Jin said excitedly. By moving with the gravity waves, we're getting much clearer readings. These patterns, they're showing us something incredible. Ji-ho moved to her station, studying the data. What he saw made him pause. This can't be right, he said softly. According to these readings, the black holes aren't just affecting space around them. They're changing the basic rules of how space works. What do you mean? Hai-1 asked, joining them. Our current models of space and time. They're too simple, Ji-ho explained. These black holes are showing us that space itself is more complex than we thought. More alive. The team gathered around the displays, watching as their probe, now moving smoothly through the gravitational waves, sent back data that would change humanity's understanding of the universe. Their crisis had led them to a discovery far more important than they had imagined. In saving their probe, they had stumbled upon a fundamental truth about space itself. Now they just had to figure out what it meant. 1 year after Hawking's dream began its mission, Ji-ho stood in Stockholm's Grand Concert Hall. Around him sat the world's greatest scientists, gathered for the Nobel Prize ceremony. His whole team was there, dressed in formal clothes and trying not to look nervous. The speaker at the podium described their achievements. Their discovery has completely changed our understanding of space, time, and gravity. The quantum patterns they found near black holes have led to new theories about how the universe works. Ji-ho thought back to that first night in his office when he noticed something strange in the telescope data. He could never have imagined where that discovery would lead. In the past year, their work had created changes far beyond astronomy. The quantum patterns they found helped scientists to develop new technologies. Yi Jin's quantum computing methods were being used to make better computers. Min Qi's AI systems were helping solve complex problems in many fields of science. Even space travel was changing. Du Hyun's technique of riding gravitational waves had shown new ways to move through space using less fuel. Space agencies around the world were building probes with their QG-LUO technology, ready to explore more distant parts of space. The speaker called them forward to receive their prize. As Ji-ho walked up with his team, he saw Dr. Choi in the audience, smiling proudly. She had helped spread their discoveries to scientists everywhere, admitting that sometimes the best discoveries come from questioning what we think we know. After the ceremony, the team gathered in a quiet room away from the crowds. They still had work to do. Hawking's dream was still sending back data, showing them new things about their binary black holes. Did you see the latest readings? Hai-1 asked. The gravity patterns are teaching us about the beginning of the universe itself. And my AI found something else in the data, Min Qi added. The way space bends near the black holes. It might help us understand dark matter too. The quantum effects we discovered might have other uses, Yi Jin said. Some engineers think they could help build better spaceships, maybe even help humans travel deeper into space. Do Hyun looked out the window at the stars appearing in the evening sky. 10 years ago, finding a black hole meant looking for X-rays or watching stars move. Now we can almost see them directly, thanks to quantum patterns in space itself. Jaiho listened to his team talk about their ongoing work. The Nobel Prize was a great honor, but it wasn't the end of their story. It was just the beginning. Their discovery had opened new doors for human knowledge, and they still had so much to learn. "We should get back to the lab soon," he said. "Those black holes still have more secrets to share." The others nodded, eager to return to their research. They had proved that human curiosity and creativity could solve the universe's biggest mysteries. Their method of finding black holes had shown that space was more amazing than anyone had imagined. As they left the ceremony, they talked about their next projects. The universe was vast and full of mysteries, but humans were getting better at solving them. Thanks to their work, future scientists would have new tools and ideas to explore the cosmos. The binary black holes still danced their cosmic dance, now watched by humanity's ever-improving eyes. And somewhere in the vast darkness of space, other mysteries waited to be discovered by those brave enough to question how things work and imagine new ways to find answers.